Design of light gauge steel frame for building structures with FrameCAD structure. A tutorial series by engineer Siraj Biswas. Chartered engineer, Institute of Engineers, India. Gold medalist in engineering stream, University of Mysore. M.Tech in structural engineering, IIT, Delhi. Sun certified Java programmer, Sun Microsystem, USA.
This section we shall learn the creation of trusses above the walls of the first floor. So before that, we must have a look at the roof plan. We already discussed about this roof plan. This part is a gable type of thing, but this is having a parallel cord truss. So this also will learn. After watching the roof plan, now let us make one more layer, new layer, that will be roof poly. Let us make the color of this cyan. Okay, cyan. Okay, so let us change the color to cyan. Okay, now let us make, before we need to draw a line here, so let us make the required rectangle which will be required for us to create the roof. Now this is one rectangle, then this is again, here also we'll need some line. This is rectangular command again. Intersection, we finish the rectangle, then again we need to draw a rectangle here. I see rectangle, then we have to draw a rectangle here again. We do not require these lines anymore. Let us delete them. Now let us go to the command bar and write lay ISO. Select this newly created rectangle. So before that, lay on ISO. We'll need some reference coordinate as well. So let us draw a line here. Again, draw a line here. Again, draw a line here. Again, draw a line. So lay ISO. The command, select the line, copy, CO copy, enter, select the base point and paste it to the destination point. So this will not be required anymore, this will be also not required anymore, and this will be also required not anymore. So now lay on ISO. So we have this truss, our load bearing wall outline. Now we have missed one of the wall, so let us, which is again load bearing for these trusses. So let us make a center line from this and draw a perpendicular up to this point. Extend it to here. Delete this point. Now let us move this point line. Move, enter. Select a base point and keep it at destination point. So these are our load bearing walls, and rest of all the walls shall be non-load bearing. So after drawing a polyline and deleting those extra line which was created by Lay ISO, this polyline is roof poly in the layer of roof poly, this one, and this one is in joist poly. We should convert it also in roof poly. So let us match it. So it has converted into roof poly. Now after this, we should define which are roof projections line. So command for and which are support line. First let us make support line SL in the command bar. SL. So this is our support line. This is our support line. This is also our support line. This is also our support line. This is also our support line. Enter. Enter. For the support line, SL, the command for support line. So this will be one of our support line. Enter. This will be SL, enter, then enter, SL, enter, SL, then enter. We have to bring one support line also, one more support line also. This is the load bearing wall for the trusses. So let us draw a line and let us take a line from its midpoint. Trim this line here and extend this line EX. Delete this line. Now move this line up. Move command, then select and take the enter, take the displacement point and take it to the destination point. Enter. So this line has to be also coded as support line. SL, enter, select the line, enter. So all these lines has been coded as support line. Then now we will draw the roof line. So for that, CRL is the command. Create roof line. CRL stands for create roof line. So to create roof line, we need certain other lines also. So let us drop a perpendicular here. Let us drop a perpendicular here, and let us join these two lines. So now go to CRL, select this point, then this point, then the last point. Now the it is asking whether you want your hip to on the left hand side, so enter hip. Then it is asking for whether you want a hip on the right hand side, enter H. So the roof line has been created. Now let us create roof line for this. This is our hip side. Take it to this point. Then hip, enter. Then this, at this point it will be saddle. Then S, enter. So saddle has been created, you can see. Again for this also, CRL, select this point, go to this point, H, enter, S, enter. Now this is the last roof line. Now CRL, now this is the gable side, H, G, enter, and S for saddle, enter. So our roof line has been created. Now before we create the trusses, we must set the truss properties. So truss setting is command is T set. So our roof slope is 15 degree. Total 6550. Let us take a color. See, this color number 30. And truss spacing, we shall have first truss spacing as 1200. First anchor truss is at say 900. Anchor truss spacing 900. First jack raptor, keep it default. Jack raptor truss offset, we do not need any truss or ceiling tiles. Now truss spacing type, what is there? Roof slope is 15 degree. Reduce level 6500. Truss spacing 12200. First arm 900. Again for jack, this we keep as it is default. Ceiling tiles, let it be default. Let all of them as default. Load, we have already defined. Roof live load is 0.65. We have to check the roof dead load. Let us go back to our Excel. Our roof load is 0.45 kN per meter square. See, we have created a beam here, so it should have been created actually at this level. Take this point at first floor level and delete it from here. Provide support to the trusses. For this line, we have extended this line and coded this one, and this one, and coded them as support line. So Now go to our 3D model. Now let us issue a command of T3D. Let us issue a command of T3D. So you can see the trusses has been created in the 3D model. Let us go back to the layout. We have to make these trusses as parallel chord trusses. So to make that, first we have to decide what is the height we can get at parallel chord trusses, and see at this point it will decide the RL of a parallel chord truss. So we have to certain alignment in AutoCAD drawing. Let us check with AutoCAD drawing. Now the truncated truss will have this kind of profile, you can see, and if it has a constant depth, so then its eave level will be at 0.639 mm and the eave height will be DLI 411 mm. So let us go to the frame cut file, list all these truss 1, 2, 3, 4. Pitch information, sailing pitch we enter 15, height information, this is, you have seen 411, left heel has 411, right heel has 411, wave information, type 1 will have this kind of wave. So material LE keep. Okay. So this has been listed LI. Let us check. Okay. Now let us go to the 3D model and make T3D again. T3D. Go to view, 3D orbit, constraint. So these are the trusses. So these points we can make a straight to match up with this joint to create a junction of this. So we have to keep 250. That can be done in the AutoCAD file generated by this software. So this will be done later. Now, as of now, let us go back to the website. So our truss generation is complete. In next section, we shall label all these truss wall panel, and then we shall give a PUA command where the studs will be placed under the joist. So at first floor we do not require double stud, back to back stud for load bearing wall, because they will be carrying trusses which are very lightly loaded. So actually we should change truss stud, type in that. So but this is a tutorial, so that will make the process long, so we are not doing it. So you can do it with the list command. So let us now save this file. Go to file, save, and close the file.